Imagine a place where there is no sound, there is no wind, no breath, and no life. There is only an endless heavy silence that has lasted for billions of years. This is the space between the stars. It is a vacuum, a vast ocean of nothingness that stretches out forever. It is darker than the darkest night you have ever known on Earth. In this place, the cold is absolute. It is a deep, freezing temperature that is almost impossible for a human mind to truly understand. If you were to step out into this void, the heat would leave your body in an instant. This is the deep dark, the lonely backyard of the universe. Usually nothing happens here. For eons, particles of dust just float, drifting aimlessly. But right now, something is disturbing the peace. Something is tearing through the silence. It is a traveller. Astronomers on Earth have named it 3I Atlas. The name sounds technical, but the object itself is a monster of rock and ice. It is not small and it is not stopping. It is moving with a speed that defies common sense. It travels at 130,000 miles per hour. To give you an idea of how fast that is a bullet fired from a gun, it's like a crawling insect compared to this object. At this speed, you could travel around the entire Earth several times in just 1 hour. It moves with a violent, silent purpose, rushing toward the only source of warmth in this neighbourhood, our sun. The date is October 29th, 25. On Earth, people are going about their normal Tuesday. They are drinking coffee, driving to work, checking their emails and preparing for the upcoming Halloween festivities, but millions of miles away in the silent vacuum a rare cosmic event is taking place. Today is the day of the year perihelion. Perihelion is a word that scientists use to describe a very specific moment. It comes from Greek words meaning near and sun. It is the point in an object's path where it gets closest to the star it is orbiting. For a comet or an asteroid, perihelion is the most dangerous time of its life. It is the moment of maximum stress. As 3I Atlas rushes toward this point, the sun is no longer a small friendly yellow dot in the sky. It is a raging, burning giant. The radiation is intense. The heat is blasting against the frozen surface of the visitor. This is the test. Will the visitor survive the heat, or will it crack and break apart into a million pieces? To understand why this moment is so tense, we must understand what 3I Atlas actually is. It is what scientists call an interstellar object. This is a very important distinction. Most of the comets and asteroids we see are locals. They were born here in our solar system. They are like neighbours who live on the same street. Think of Halley's Comet. It is famous, but it is predictable. It travels in a loop around the sun, goes out and comes back every 76 years. It is like a dog on a very long leash. We know where it is, and we know when it is coming home. Atlas is different. It is not a neighbour, it is a stranger. It does not have a loop for an orbit. It is not on a leash. It came from somewhere else entirely, perhaps from a different star system that exploded long before humans walked on Earth, or from the cold dark clouds between the stars. It has been drifting alone in the dark for millions of years. It has passed other stars and other worlds, never stopping, just passing through. Now it has entered our solar system, but it will not stay. Its path is shaped like a hyperbola, which means it is an open line. It will swoop down, wrap around the sun to gain speed, and then shoot back out into the deep dark, never to return. We will never see it again. This makes the object rare. In the entire history of astronomy, we have only seen 2 other visitors like this before. One was called Oumuamua, and the other was called Borisov. They were surprises. They taught us that our solar system is not a closed bubble. We are living in a busy galaxy, and sometimes things drift through our yard. But 3I Atlas feels different. It is bigger, it is faster, and it is darker. On Earth, the atmosphere in the scientific community is electric. Inside the control rooms of NASA in the United States and the ESA in Europe, the mood is a mix of high excitement and extreme focus. Men and women in smart clothes are staring at computer screens watching lines of data scroll by. Giant telescopes in Chile and Hawaii are pointed at the same spot in the sky. They are trying to learn everything they can in the short time they have. They want to know what it is made of. Is it iron? Is it ice? Is it rock? Does it contain water from a different sun? NASA has issued a press release. They have told the public that there is no danger. They have calculated the trajectory, the path the object will take with extreme precision. They used mathematics that has been proven to work for centuries. According to their numbers, 3I Atlas will miss Earth by a very comfortable margin. It will pass millions of miles away. There is no chance of a collision. It is a scientific opportunity, they say. It is a gift from the stars. And yet there is a feeling in the air that is hard to shake. When you look up at the night sky on this night in October, you cannot see the object with your naked eye. It is too dark and too far away, but knowing it is there changes how the night feels. It brings a sense of anticipation and a feeling of waiting for the other shoe to drop. There is something haunting about an object that comes from the unknown. The local comets are predictable, we understand them, but an interstellar visitor represents the chaos of the universe. It reminds us that we are very small and the universe is very big. We like to believe we are safe on our blue planet, protected by our atmosphere and our distance from other stars. But when a rock the size of a mountain screams through our solar system at 130,000 miles per hour, it pierces that bubble of safety. It brings a lingering what if to the back of the mind. What if the calculations are slightly wrong? What if the heat of the sun changes the object's path? When a comet gets close to the sun, the ice on its surface turns to gas. This gas shoots out like a jet engine. It can push the rock in a new direction. This is called non-gravitational acceleration. It is a fancy way of saying that the rock can steer itself. What if 3I Atlas steers itself toward us? The scientists say this is unlikely. They say the math is solid. They speak with calm, reassuring voices on the television news. They smile and point to charts and diagrams. They are the experts, the guardians of knowledge. We trust them because we have to. But as the sun sets on October the 29th, 25, and the world goes to sleep, the visitor is there. It is swinging around the sun, bathed in blinding light, enduring the fire. It is a silent, dark messenger from the deepest parts of the galaxy, carrying secrets we may never solve. It rushes past us in the dark, indifferent to our fears, indifferent to our existence. It is just a traveller passing through the night, but for a few short weeks it has made the entire human race look up and wonder what else is hiding in the deep, dark void. There is a profound irony at the heart of modern astronomy. We possess instruments capable of seeing galaxies born just a few 100 million years after the Big Bang. We can detect the heat signature of a planet orbiting a distinct star, and we can map black holes that are invisible to the human eye. Yet when an object enters our own solar neighbourhood and approaches the most dominant force in our system, we become utterly blind. This is the situation that defined the late months of the year for the observers tracking 3I Atlas. As the object accelerated toward its moment of truth, it did not move into the darkness of deep space where our telescopes shine brightest. Instead, it fell directly into the glare. To understand this blindness, one must understand the simple but unforgiving geometry of our solar system. Picture the Earth and the Sun as 2 points on a flat sheet of paper. Now draw a line connecting them as 3I's Atlas raced inward from the outer edges of the system. Its path took it behind the Sun relative to our position on Earth. This alignment is what astronomers call a solar conjunction. In simple terms, a solar conjunction happens when a planet or other body passes on the opposite side of the Sun from the Earth. For a radio signal or a beam of light to reach us from the object, it has to pass extremely close to the Sun. This creates an insurmountable wall of interference. The Sun is not just a ball of fire, it is a massive generator of radio noise, charged particles and blinding light. Trying to see a small chunk of ice and rock next to the Sun is like trying to spot a single grain of dust floating next to a stadium floodlight while standing a mile away. This geometry forced a terrified awareness upon the scientific community. The most advanced eyes humanity has ever built, the Hubble Space Telescope and the James Webb Space Telescope, were rendered useless. Both of these machines are engineering marvels, but they are also incredibly fragile. They are designed to capture tiny, faint photons of light from the darkest corners of the universe. They are essentially giant light buckets. If you were to point the Hubble Space Telescope anywhere near the Sun, the intensity of the light would fry its sensitive sensors in an instant. It would be like looking at the Sun through a magnifying glass, but thousands of times worse. The telescope's internal mirrors would focus that heat and light, destroying the instruments permanently. The James Webb Space Telescope has an even stricter limitation. It detects infrared light, which is essentially heat. To work, it must stay incredibly cold, protected by a massive sunshield that blocks the heat of the Sun, Earth and Moon. The telescope can never under any circumstances look in the direction of the Sun. If it did, its coolant systems would fail and the machine would become a piece of floating space junk. Therefore, as 3I Atlas approached the Sun, an exclusion zone was drawn across the sky. A do not look zone. The timeline of this blindness created a period of intense psychological pressure. The window of observation slammed shut around October 21st. Before this date, the data was flowing in spectroscopy trajectory updates and brightness measurements. But on October the 21st, the angle between the comet and the Sun became too small. One by one, the telescopes on Earth and in space had to turn away to protect themselves. From late October until earlier December, the object entered the lost weeks. This was a period of roughly 45 days where 3i Atlas was effectively gone. This silence was agonizing because of when it was happening. This was not a quiet cruise through empty space. The object was diving toward its perihelion, the point in its orbit closest to the Sun. This is the most violent and critical phase of any comet's life. At perihelion, the heat increases exponentially. The surface temperature of the object rockets from freezing cold to hundreds of degrees Celsius. The gravitational pull of the Sun tugs at the structure of the rock, creating immense tidal forces that try to rip it apart. It is during this exact window when the comet is under the most stress that we lost the ability to watch it. Imagine a doctor monitoring a patient's heart. The patient is stable, but then they are wheeled into a surgery room for a high-risk operation. Just as the surgery begins, the monitors are turned off, the doors are locked, and the doctor must wait in the hallway for 6 weeks without a single update. That was the feeling in mission control centers around the world. Was the object disintegrating? This was the primary fear. Many comets that pass this close to the Sun simply vanish. The heat turns their ice into gas so violently that the entire structure crumbles into a cloud of dust. If 3i Atlas was just a normal dirty snowball, the Sun would likely destroy it during these weeks of blindness. When we looked back in December, we might find nothing but a fading smear of dust. However, if the object was artificial, or if it possessed the strange solid structure suggested by the early data, the stress of the Sun would reveal it. The lost weeks became a test of the object's nature. During this blackout, astronomers could only rely on mathematical models. Computers crunched the numbers predicting where the object should be if it survived. They calculated the orbit based on gravity alone, but there was a wild card: the non-gravitational acceleration. Recall that the object had shown signs of speeding up pushed by something other than gravity. If this engine, whether it was natural outgassing or something else, kicked into high gear due to the solar heat, the trajectory would change completely. Without eyes on the target, we had no way of updating the path. The object could be shifting thousands of kilometers off course, and we would not know until it emerged from the glare. The atmosphere in the scientific community shifted from excitement to a tense, quiet dread. Papers were written and rewritten. Theories were debated in hushed tones. The phrase Schrödinger's comet became a popular joke in the hallways of academia. As long as it was hidden behind the Sun, the object was both alive and dead, both a solid spaceship and a broken cloud of dust. The radio telescopes on Earth tried to listen, hoping to catch a signal through the solar interference, but the Sun was too loud. It screamed across the radio spectrum, drowning out everything in its vicinity. The only thing humanity could do was wait. As November dragged into December, the geometry slowly began to shift. The Earth continued its orbit, and 3i Atlas continued its slingshot around the star. The angle between the Sun and the object began to widen. The do not look zone was slowly receding. The blindfold was about to be lifted. The question was no longer just, what is it? The question had become, is it still there? The world prepared to turn its eyes back to the sky, hoping to see a survivor emerging from the fire. But as the first observations were scheduled for early December, no one was prepared for the data that was about to come down from the satellites. The object had not just survived, it had changed. When we attempt to solve a mystery as complex as Oumuamua, we are forced to look beyond the shapes and speeds we can see with our eyes. We have to look at the ghost of the object, the chemical fingerprints it leaves behind in the light. This brings us to one of the most sophisticated aspects of modern astronomy and the specific capabilities of instruments like the James Webb Space Telescope. While we often think of telescopes as giant cameras taking pictures, their most valuable function in this context is something called spectroscopy. This is the science of taking light and breaking it apart, much like a prism turns sunlight into a rainbow to reveal the secret ingredients of the universe. Every chemical element and molecule in the cosmos has a unique signature, a specific barcode hidden within the light spectrum. When sunlight hits an object, the atoms on that object's surface absorb very specific colors of light and reflect others. By analyzing the light that bounces back or the faint heat signatures emitted by the object, we can determine exactly what it is made of without ever touching it. For Oumuamua and for the comets we study to understand it, this method allows us to see the invisible. It allows us to look at a rock tumbling through the dark and tell you whether it is made of iron rock or ice. This is where the investigation took a dramatic and unexpected turn. In the standard model of comets, the dirty snowballs we are used to seeing, we expect water to be the dominant ingredient. Water ice is abundant in the universe. When a comet gets close to the Sun, that water ice heats up and sublimates, turning into vapor. This is what creates the beautiful glowing tails we see in the night sky. However, the deep dive into the chemical composition of objects similar to Oumuamua and the retrospective analysis of the data pointed towards something startlingly different. Instead of a water-rich body, the data suggested a chemical composition that was radically distinct from the typical comets of our solar system. The numbers pointed to a ratio of carbon dioxide to water that was approximately 8:1. This is an enormous deviation from the norm. To put this in perspective, imagine walking into a bakery expecting the smell of bread, which is mostly flour and water, and instead finding that the room is filled almost entirely with the scent of dry ice. This dominance of carbon dioxide changes everything we thought we knew about the object's behaviour and its origin. This specific ratio 8 parts carbon dioxide to just 1 part water provides the missing key to the propulsion mystery. To understand why we have to visualise the atmosphere of the object, or rather the lack of one, we need to picture the process of sublimation. On Earth, if you drop an ice cube on the pavement on a hot day, it melts into a puddle of liquid water, and then that water slowly evaporates into gas. In the vacuum of space, liquid water cannot exist. When sunlight hits typical ice, it skips the liquid phase entirely and bursts directly into gas. Now consider carbon dioxide ice. We know this substance on Earth as dry ice. It's much more volatile than frozen water. It turns into gas at much lower temperatures and with much more violence. If Oumuamua was effectively a hydrogen or nitrogen iceberg, or significantly rich in carbon dioxide, as this 8:1 ratio suggests, the mechanism of its movement becomes clear. As the sun's rays touched the surface of the object, the carbon dioxide ice deep within its structure didn't just melt, it exploded outward. This creates a phenomenon that we might call the breath of the comet. Imagine millions of tiny jets invisible to the naked eye erupting from the sunlit side of the object. Because carbon dioxide creates a transparent gas, and because the object likely had very little dust to trap in that gas, there was no visible tail. There was no fuzzy cloud for our telescopes to snap a photo of. There was only the invisible force of the gas jetting out into the void. This acts exactly like a thruster on a spaceship. The gas shoots one way, and pursuant to the laws of physics, the object is pushed in the opposite direction. This creates the extra speed, the non-gravitational acceleration that baffled scientists for so long. This finding draws a sharp line between formation conditions and artificial propulsion. For a long time, the fact that Oumuamua sped up without a visible engine led many to speculate that it must be alien technology. If it moves like a rocket but doesn't look like a comet, they argued it must be a machine. But the chemical signature tells a different story. It tells us that the engine was natural born from the specific conditions of where the object formed. The high concentration of carbon dioxide and the lack of water suggests that this object was born in a place of profound cold. Water freezes fairly easily, but for carbon dioxide to freeze solid and become the primary building block of an object, you need temperatures hovering near absolute zero. This implies that Oumuamua was likely ejected from the very outer fringes of a planetary system far beyond where planets like Earth or even Neptune would sit. It formed in the dark frozen wastes of a protoplanetary disk, where carbon and oxygen bonded in the deep freeze before being kicked out into interstellar space. The mystery of the dry comet is therefore solved not by finding a lack of ice, but by finding the wrong kind of ice. It appeared dry to our initial observations because we were looking for the signature of water. We were looking for the hydration we recognize, but the universe is vast and holds recipes for worlds that are very different from our own. Oumuamua was not a dried-out rock. It was a volatile, fizzing block of exotic ices that was slowly evaporating as it travelled. This realization forces us to rethink how we look at the universe. It reminds us that our solar system is not the standard template for everything else. There are shards of ice floating between the stars that are made of nitrogen, hydrogen, or carbon dioxide, acting as invisible rockets tumbling silently through the dark. The 8:1 ratio is not just a number. It is a testament to the diversity of cosmic chemistry. It explains the acceleration without needing aliens, and it explains the lack of a tail without needing the object to be an asteroid. It was in the end a traveller from a darker, colder place, propelled by the very substance of its own body evaporating into the sunlight. Let us shift our perspective entirely. Let us step away from the comfortable, safe explanations of astronomy and move into the realm of the worst-case scenario. This is the domain of speculation, but it is speculation grounded in engineering logic. If you were an engineer belonging to a civilization millions of years more advanced than ours, and you wanted to explore the galaxy, how would you do it? You would not build a shiny metal ship with flashing lights. You would build a fake comet. Consider the problem of interstellar travel. It is not just about speed, It is about survival. The space between stars is not empty. It is filled with microscopic dust and high-energy particles moving at incredible speeds. Over a journey of millions of years, a standard metal hull would be pitted and eroded, worn down by the friction of the cosmos. Furthermore, a metal ship is heavy, and it reflects light in a way that screams artificial. If your goal is surveillance to observe other star systems without interfering or being detected, you need camouflage. The perfect camouflage for deep space is already provided by nature. It is ice and rock. If an alien intelligence wanted to send a probe to scan our solar system, the smartest design choice would be to hollow out a natural object or construct a shell that mimics one. By using a thick layer of nitrogen water ice, or frozen carbon monoxide as the outer hull, the probe solves several problems at once. First, the ice acts as a shield against cosmic radiation and interstellar dust. As the probe travels, the outer layer slowly wears away, sacrificing itself to protect the delicate instruments inside. It is a self-healing ablative armor. This brings us to the uncanny feeling that surrounded the object known as Oumuamua. Astronomers often talk about the uncanny valley in robotics, the feeling of unease we get when a robot looks almost human, but not quite. Oumuamua occupied the uncanny valley of celestial objects. It looked like a rock, but it did not behave like one. The most suspicious characteristic was its movement. As we discussed previously, the object accelerated as it left the solar system. The natural explanation is outgassing ice melting in the sun and creating a jet of gas that pushes the object. But here is where the engineering hypothesis becomes chilling. If you were piloting a stealth craft, you would not use a glowing blue ion engine that anyone could see. You would use a propulsion system that mimics nature. You would vent gas. By heating specific sections of the frozen surface, an internal computer could create jets of gas that look exactly like a natural comet melting. This outgassing allows the probe to adjust its course speed up or slow down, all while maintaining the illusion of being a dumb rock tumbling through the dark. It is the ultimate stealth technology, hiding the engine exhaust by making it look like natural evaporation. Then there is the tumbling. Most asteroids and comets spin in a relatively simple way. Oumuamua, however, was tumbling chaotically end over end. While scientists struggled to explain how a collision billions of years ago caused this, an engineer might see something else. If you have a fixed sensor, a camera, or a listening device bolted to the side of your ship, you are limited in what you can see. But if your ship is tumbling wildly, your sensors sweep across the entire sky. That chaotic spin allows you to scan everything: the Earth, the Sun, Jupiter, and the empty void, all without needing complex moving turrets. It creates a full three-dimensional map of the environment. To the observer, it looks like a chaotic wreck. To the probe, it is a deliberate panoramic sweep of the target system. The atmosphere of this hypothesis is heavy with the feeling of being watched. It suggests that the galaxy is not a lonely wilderness, but a crowded room where everyone is keeping quiet. It implies that we are the noisy neighbours in a silent neighbourhood, broadcasting our television and radio signals into the dark, while sophisticated probes drift silently through our backyard disguised as debris, taking notes and moving on. But perhaps we are looking for the message in the wrong format. We tend to look for radio waves, laser pulses, or clearly defined geometric shapes. What if the message was not broadcast from the object but written into the object? This brings us to the concept of chemical steganography. Steganography is the art of hiding a message in plain sight so that no one even realizes there is a message to decode. Radio signals are fleeting. They weaken over the distance and can be blocked by planets or stars. If you want to send a message across the galaxy, a message that will last for billions of years, you do not use energy, you use matter. You write your message in atoms. The chemical composition of Oumuamua was unusual. It was covered in a reddish sludge likely caused by organic molecules bombarded by radiation for eons. We analysed the light reflecting off it to guess what it was made of. We found carbon, we found hydrogen, and we found hints of other elements. But we generally stopped there, assuming the mixture was a random result of cosmic cooking. A deeper look suggests a fascinating possibility. In chemistry, elements come in different weights called isotopes. For example, there is carbon-12, which is common, and carbon-13, which is heavier. In nature, these exist in specific known ratios. But an advanced civilization could manipulate these ratios. They could build a material where the ratio of isotopes acts as a binary code. Imagine a long chain of molecules. If a molecule has carbon-12, it represents a 0. If it has carbon-13, it represents a 1. By alternating these isotopes in a synthetic polymer on the surface of the object, you could encode the entire history of a civilization star, maps or biological data into the dust itself. This method of communication is incredibly durable. A block of encoded plastic or rock can survive floating in the vacuum of space for eons. It does not require batteries, it does not require a transmitter, it just waits for someone smart enough to capture it and put a sample under a mass spectrometer. The atmosphere here changes from the fear of surveillance to the tragedy of a missed connection. The intricate dance of atoms on the surface of Oumuamua might have been a library card. We looked at the object, we measured its brightness, and we tracked its speed, but we never landed on it. We never scraped a sample of that red dust to analyze the isotopic ratios with high precision. We assumed the chemistry was just the random chaos of the universe. But what if that chaos was actually a highly ordered language we simply did not expect to see? We are like a person finding a flash drive on the beach and skipping it across the water like a stone because we do not recognize what it is. The tragedy of the message in the molecules theory is that it requires a Rosetta Stone. Even if we realized the isotopes were a code, we would need to know how to read it. Without a primer, without a key to the language, a history of the galaxy looks exactly like a random pile of organic sludge. We may have been staring directly at a greeting from another world, but because it was written in the subtle language of neutrons and protons rather than English or mathematics, we let it slip away into the dark. The object is gone now, taking its potential library of secrets back into the silent void. The initial panic of the invasion hypothesis eventually gives way to a much quieter, heavier realization. As the scientists peel back the layers of the signal coming from the comet, they find a pattern that repeats with mathematical precision, but it lacks the chaotic variation of a living conversation. There is no variation, no reaction to our presence, and no new data being generated. The signal is not a greeting. It is an automated loop. It is a beacon left on a timer broadcasting into the void long after the hand that set it has turned to dust. This brings humanity face to face with the concept of the ghost ship. We realize that the comet is not a warship coming to conquer us, nor is it an ambassador coming to trade. It is a technological fossil. The civilization that built it is gone. We are not looking at a visitor. We are looking at a tombstone flying through space. This discovery shifts the global atmosphere from terror to a profound aching melancholy. We are standing on the shore of the cosmic ocean, finding a message in a bottle only to realize the writer drowned millions of years ago. This touches upon the scientific idea of the Fermi paradox. For decades, astronomers asked, where is everybody? If the universe is so old and vast, it should be full of life. We should have heard from them by now. The silence of the universe was always frightening, but the comet offers a specific, tragic answer to the paradox. It suggests that civilizations might arise, build wonders, and launch probes, but they do not last. This is where the theory of the Great Filter becomes the central topic of discussion. The Great Filter is the idea that there is some barrier, some impossible challenge, that prevents life from surviving for a long time. Perhaps it is nuclear war or climate collapse or a biological plague or the invention of artificial intelligence that goes wrong. We look at the comet and wonder, what killed them? Did they destroy themselves, or did the universe destroy them with an asteroid or a dying star? The comet offers no answer, only the silence of its machinery. The timescales involved are almost impossible for the human mind to truly grasp. This connects to the concept of deep time. To us, history is measured in centuries or millennia. The pyramids are old to us, but in the scale of the universe, the pyramids were built a split second ago. The probe inside the comet might have been travelling for 50 million years. When this object was launched, humans did not even exist. Dinosaurs might have been walking the earth, or perhaps early mammals were just beginning to scurry in the undergrowth. The beings who built this machine lived their lives, fell in love, fought wars, created art, and looked up at the stars, all while Earth was a primitive jungle. Now not even their bones remain. Their home planet might have been swallowed by its own sun or drifted away into the dark. There is a deep tragedy in the idea of technological artifacts outliving their makers. The probe is functioning perfectly. Its nuclear batteries are still warm. Its computer processors are still calculating the trajectory. Its gold-plated antenna is still humming with energy. The machine is immortal compared to the biological creatures that built it. It is a perfect servant waiting for orders that will never come. It continues its mission with blind obedience, unaware that it is an orphan. This creates a feeling of empathy in the human population. We stop seeing the aliens as monsters and start seeing them as lost brothers and sisters in the struggle for existence. We imagine their final days. Did they know the end was coming? Is this comet a frantic attempt to save their knowledge? A backup drive for an entire species? The signal we are decoding might be their music, their poetry, or their genetic code sent out in a desperate hope that someone somewhere would remember them. The comet becomes a sacred object in the sky. It is no longer a threat, it is a memorial. The best scientists on Earth treat the data with the reverence of archaeologists brushing dirt off a sacred bone. They realize that we are the sole custodians of this extinct culture. If we fail to understand them, their memory dies a second, final death. This scenario forces humanity to look in the mirror. If a civilization advanced enough to travel between stars can go extinct, what does that mean for us? We are fragile. We are squabbling over borders and resources on a single small planet. The ghost ship is a warning. It tells us that intelligence is not a guarantee of survival. We are walking a tightrope and the fall is very far. The silence of the ruins inside the comet is louder than any explosion. As our probes eventually match speed and cameras get close to the object, we don't see weapon ports or invasion hatches. We see pockmarks from millions of years of micrometeoroid impacts. We see metal that has been eroded by the dust of the galaxy. It looks tired. It looks like an old traveller that has walked across a continent and just wants to rest. The information stored inside is likely static. It is a snapshot of a dead world. Interpreting it becomes the greatest challenge in history. We have to decipher a language with no native speakers left alive. We have to understand math and physics notation written by hands that have not moved in eons. But the motivation is no longer fear. It is a solemn duty. We owe it to them to listen. In the end, the ghost ship scenario changes our relationship with the universe. We realize we are not necessarily the first, and we are certainly not the masters of space. We are just the current occupants. The universe is a graveyard of potential, and the comet is a single flower growing on a grave. It brings a sense of cosmic solidarity. We are alone, but we share the darkness with the echoes of those who came before. The comet continues its journey, passing Earth, moving back out into the cold dark, a lonely messenger, carrying a letter that took too long to arrive. We watch it go not with relief, but with a heavy heart waving goodbye to the ghosts of a civilization we wish we could have met. For decades, humanity has trained its eyes and its instruments on the black abyss above, scanning for the telltale signs of a metal hull reflecting starlight. We look for shapes that defy the laws of aerodynamics, for propulsion drives that burn with the energy of a small sun, or for radio signals carrying complex mathematical sequences. We have been conditioned by our own fiction to expect the visitors to arrive in armadas, their ships blotting out the sun, their intentions announced with fire and noise. We expect a knock at the door. But what if the knocking never comes because the visitor doesn't need a door? What if the payload isn't a machine but a seed? This brings us to the most unsettling and quietest possibility of contact, the panspermia hypothesis. Specifically the concept of directed panspermia. This theory suggests that life on Earth may not have started here by accident, or that life elsewhere is not waiting to be found, but is instead being actively distributed across the galaxy. In this scenario, the alien civilization does not send explorers. They send gardeners, and the ships they use are no larger than a grain of sand. To understand this, we must first look at the microscopic world. We tend to think of life as fragile. We think of humans needing specific temperatures, oxygen, and water to survive. But on our own planet, we have found biology that breaks these rules. We call them extremophiles. These are bacteria and tiny organisms that thrive in boiling acid, in the crushing pressure of the deep ocean, and even inside nuclear reactors. The most famous of these is the tardigrade, often called the water bear. This microscopic animal can survive the vacuum of space. It can be frozen to nearly absolute zero, the coldest temperature possible, and it can be roasted at heat levels that would sterilize a hospital. When conditions become impossible for life, these creatures do not die. They enter a state called cryptobiosis. They dry out, curl up, and essentially turn into a glass-like biological statue. They stop their metabolism completely. They wait. They can wait for decades or perhaps centuries. When water returns, they simply wake up and continue as if nothing happened. Now imagine a civilization that has mastered this biology. They do not need to build a ship capable of traveling faster than light. They do not need to solve the problem of keeping a crew alive for 10,000 years. They simply need to encode their biological blueprint, their DNA or its alien equivalent, into a shell tough enough to survive the journey. This changes the image of first contact entirely. It is not a dramatic landing. It is a silent, invisible rain. Every day, roughly 100 tons of space dust falls into Earth's atmosphere. It is mostly debris from comets and asteroids, tiny particles that burn up as shooting stars or drift slowly down to the surface. In the directed panspermia scenario, hidden within that natural dust is a manufactured payload. These biological seeds would be designed to survive the intense heat of entering our atmosphere. They would not burn up, they would ride the air currents. Picture this. You are standing outside on a clear night looking up at the stars waiting for a sign. You see nothing but the moon and the constellations, but all around you, falling softly onto your skin, into your hair and into the grass at your feet, are millions of alien visitors. You breathe them in, you drink them with your water. They settle into the soil of your garden. This leads to the terrifying concept of assimilation rather than invasion. Our movies depict aliens blowing up our cities because that is how humans fight. We understand war, we understand territory, but a biological civilization might not care about governments or borders. Their goal might not be to conquer but to integrate. If these seeds are compatible with our biology, the result is not a war but a rewrite. This is where the idea moves from fascinating to horrifying. In biology, we have something called horizontal gene transfer. This is where an organism transfers genetic material to another one that is not its child. Bacteria do this all the time. They swap superpowers, like resistance to antibiotics, simply by being near each other. If the alien rain contains genetic code that can interact with Earth life, the invasion happens inside our own cells. A virus, for example, is just a packet of code that hijacks a cell and forces it to build more viruses. An alien seed might act similarly, but with a more complex purpose. It might not kill the host. Instead, it might slowly alter the host. Over generations, the native life of the planet begins to change. New traits appear. The evolutionary path steers in a new direction, one that was planned millions of years ago in a laboratory on a distant star. We would not be wiped out. We would be updated. We would become the children of the visitors without ever seeing their faces. This raises a profound ethical question for the gardeners. Is it right to seed a world if a planet already has life? Sending these seeds is an act of aggression. It is biological colonialism. It imposes a new order on an existing ecosystem. But if the planet is dead like Mars appears to be, then seeding it is an act of creation. It is the ultimate gift, the spark of life in a dead universe. However, there is a darker interpretation. Perhaps the seeds are not gifts. Perhaps they are lifeboats. Imagine a civilization facing their own extinction. Their sun is dying or their planet is falling apart. They know they cannot escape in ships. There is nowhere to go and not enough time. So they decide to save the only thing that matters, their information. They break their biological code down into data encapsulated in tough microscopic shells and blast it out into the universe in every direction. They are not trying to conquer. They are trying to prevent their total erasure from history. They are planting themselves in the soil of other worlds so that some part of them will live on. In this light, the invisible rain is a desperate scream for survival. When we breathe in that dust, we are becoming the vessel for a ghost. The scariest realization of the panspermia hypothesis is that it might have already happened. Scientists have often looked at the explosion of life on Earth, the sudden appearance of complex organisms hundreds of millions of years ago, and wondered why it happened so fast. Evolution is usually slow. What if the jumpstart came from above? If this is true, then we are not waiting for the aliens to arrive. We are the aliens. The separation we feel between us and the stars is an illusion. We are made of the same star stuff, not just chemically, but biologically. The dust trails falling through the atmosphere are not bringing strangers, they are bringing our distant cousins, or perhaps the next software update for our DNA. We look at the sky and fear the arrival of monsters, but the true transformation is happening at a level too small for the eye to see in the silence of a falling particle in the microscopic war, or the microscopic love affair between our cells and the invisible rain. The invasion is over before we even knew it began, and the victory is total because there is no one left to fight it, only the new version of us quietly tending the garden. The silence in the control room was not the silence of peace. It was the silence of a held breath, a collective pause before a plunge. For decades, the search for extraterrestrial intelligence had been a game of statistics and hope. It was a quiet science, filled with false alarms and background noise. But when the verification finally came, it did not arrive with fanfare. It arrived as a stream of data that refused to be anything other than artificial. The signal was not a natural pulse. It was a structured sequence, a prime number counting loop that repeated with a precision that nature does not produce. It was the techno-signature humanity had spent 60 years waiting for. However, the moment the confirmation turned from highly probable to certain, the dream of scientific unity shattered against the hard wall of geopolitical reality. The scientists had a plan. It was called the Declaration of Principles Concerning Activities Following the Detection of Extraterrestrial Intelligence. It was a gentleman's agreement, a document signed by academics and researchers. It stated that if a signal was found, the discoverer would verify it, notify the rest of the scientific community, and then announce it to the world openly. That document lasted exactly 40 minutes. As soon as the data was flagged as a level 1 confirmation, the internet connection to the observatory was physically severed. Men in suits who had sat quietly in the background of funding meetings for years suddenly stepped forward. The protocols of the International Academy of Astronautics were replaced by the protocols of national security. The crisis began in a windowless briefing room in Geneva, 3 days after the detection. The atmosphere was thick with the smell of stale coffee and the ozone-sharp tang of overheating servers. Around the table sat a mix of astrophysicists, generals, and high-ranking diplomats. The tension was palpable because everyone in the room realized they were looking at the same data but seeing completely different things. The scientists saw a miracle, the generals saw a potential threat, the diplomats saw a chaotic mess that would destroy economies. The first major hurdle was the physics of the object itself. A general, a man used to tracking ballistic missiles and aircraft, pointed at the screen. He wanted to know interception times. He wanted to know when we could launch a rocket to meet the visitor to inspect it or perhaps to defend against it. The lead astrophysicist had to explain the brutal reality of orbital mechanics and energy. She explained that the object was not drifting. It was travelling at a significant fraction of the speed of light. To be precise, it was moving at roughly 10% of light speed. She used a simple analogy to make them understand. She told them to imagine standing on a train platform. A bullet train is passing through the station, not stopping moving at full speed. You are standing there with a bicycle. You cannot pedal hard enough to catch the train. You cannot throw a rope to hook onto it because the difference in speed would tear your arm off. The object was passing through our solar system, but it was not stopping. It was a flyby. To match its speed, humanity would need propulsion systems that did not exist. We would need to accelerate a spacecraft to 30,000 kilometers per second. Our fastest probes, like the ones sent to the outer planets, moved at a tiny fraction of that speed. We were statues trying to catch a bolt of lightning. There would be no meeting, no handshake, and no interception. We were simply watching a car drive past our house on a dark highway. Then came the issue of communication. This was the second failure of the protocol. The SETI protocols suggested that no response should be sent until a global consensus was formed. But how do you form a consensus among 8 billion people and 200 distinct nations? The debate in the room quickly turned hostile. One faction argued that we must beam a message of peace immediately. They wanted to send mathematics, music, and maps of our biological structure. They argued that silence was cowardly. The opposing faction, mostly intelligence officers, argued for the dark forest approach. They claimed that revealing our technological level and our exact location was suicidal. If the object was a probe, speaking to it might trigger a response we could not survive. They argued that we should remain silent observers hiding in the grass while the predator walked by. But the laws of physics offered a cruel twist to this debate as well. The speed of light delay made the argument almost academic. The object was currently passing the orbit of Jupiter. Even at light speed, a radio message sent from Earth would take nearly 35 minutes to reach the object. If the object replied immediately, the answer would take another 35 minutes to return. That is a round-trip time of over an hour, but the object was moving away fast. By the time we crafted a proper message, a process that would take weeks of bureaucratic fighting, the object would be billions of kilometers further out. The delay would grow to hours, then days. We were not starting a conversation. We were shouting letters into the mail slot of a departing truck. While the powerful argued in the briefing room, the secret could not be kept. This was the final collapse of the protocol. In the age of the internet, secrets have a half-life measured in hours. A graduate student at a partner observatory in Chile noticed the telescope tracking data. She saw where the great dishes were pointing. She saw the spectral analysis logs. She posted a question on a scientific forum. That question was picked up by an automated aggregator. Within 6 hours, the rumor was trending. Within 12 hours, amateur astronomers with backyard telescopes were confirming that something was wrong in the sector of the sky near Jupiter. The panic was not the Hollywood style of rioting in the streets, at least not initially. It was a digital panic. Stock markets crashed in Tokyo and New York because algorithms didn't know how to price the future of the human species. Religious leaders issued conflicting statements. Some claimed it was demons, others claimed it was angels. The indifference of the cosmos was crashing into the fragile narratives humans tell themselves. Back in the briefing room, the realization set in. The post-detection protocol assumed humanity would act as one. It assumed we would have time. It assumed the aliens would pause to talk. None of this was true. The object was a mute silver traveler indifferent to our borders, our politics and our fears. It was not here to conquer us, and it was not here to save us. It was simply passing through. The crisis wasn't that the aliens were attacking. The crisis was that we were utterly irrelevant to them. We were ants arguing over who controls the anthill, while a giant stepped over us without looking down. The lead scientist looked at the clock on the wall. Every second that ticked by, the visitor moved 30,000 kilometers farther away. The window for high-fidelity scanning was closing, while the diplomats argued over the wording of a press release had already been leaked, and the generals argued over a defense strategy against a ghost. The universe continued to tick. The ultimate humiliation was that humanity had finally found proof that we are not alone, and in that same instant we discovered that we were too slow, too young, and too divided to do anything about it. The protocol had failed because it was written for a fantasy world where humans were rational and the universe was waiting for us. In reality, the clock was racing and we were still trying to tie our shoes. The silence of the universe has always been our greatest mystery. For decades, astronomers pointed their radio telescopes at the sky, listening for a whisper, a signal, or a beat. We expected a greeting. We hoped for a sign that we were not alone. When all we heard was static and the random noise of dying stars, we called it the Fermi paradox. We asked, where is everybody? We thought the silence meant the galaxy was empty. We thought it was a tragedy, but looking at the data from 3i Atlas now, I realize we were wrong. The silence is not a tragedy. The silence is a shield. To understand why 3i Atlas terrifies me, you have to understand the concept of the dark forest. Imagine the universe is a massive dark forest at night. It is not empty, it is full of life, but it is also full of hunters. In this forest, every civilization is like an armed hunter stalking through the trees. He must move quietly, he must breathe slowly, he must step over dry leaves without making a sound. Why? Because there are other hunters in the forest. In sociology, we apply something called game theory to this situation. It is a way of predicting how rational beings will act when they cannot trust each other. In the cosmic scale, the rules are simple and brutal. First, the primary goal of every civilization is survival. Second, civilizations grow and expand, but the total amount of matter in the universe remains constant. This creates a deadly mathematical problem. If I see another hunter in the forest, I cannot know his true intentions. Is he friendly? Is he hostile? Even if he seems friendly, now will he become dangerous in 100 years? I cannot know. And he cannot know if I am friendly. We are trapped in a chain of suspicion. Because the distance between stars is so vast, communication is too slow to build trust. By the time I say hello, he might have already fired his weapon. Therefore, the only logical move, the only way to guarantee my own survival is to shoot him the moment I see him. In this dark forest, hell is other people. Every life form is a potential threat to every other life form. The safest action is to eliminate the competition before they can eliminate you. This explains the silence. The universe is quiet not because there is no life, but because the smart civilizations know better than to speak. They are hiding. They are ghosting their planets, dampening their radio waves, and camouflaging their heat signatures. They know that to reveal your location is to invite death. And then there is us, humanity. For the last 100 years, we have been the foolish child wandering through this dark forest. We have lit a massive campfire. We have been shouting at the top of our lungs. We sent out the Voyager probes with maps to our home. We blasted radio shows, television signals, and radar waves into the deep black. We stood on a mountain and screamed, "We are here, we are here." We thought we were inviting friends to a party. In reality, we were painting a target on our backs. This brings us back to 3i Atlas. For months, we debated what this object was. Was it an asteroid, a comet, a piece of space junk? We looked for a drive signature or a communication beam. We found nothing. It was cold, silent, and dark. Because of this, many of my colleagues dismissed the idea that it was artificial technology. They argued that an alien ship would emit radiation light or energy. But under the dark forest theory, 3i Atlas behaves exactly like a piece of military technology should. If you are a hunter in the forest, you do not walk around with a flashlight turned on. You do not play loud music. You build a machine that looks like a rock. You build a machine that produces no heat. You build a machine that creates no reflection. You make it look exactly like the billions of other natural objects floating in the void. 3i Atlas is not an invasion fleet. It is too small, it is not a warship, it is a scout. Think about the efficiency of it. If a predator wants to find prey, it does not send its whole body, it sends eyes. 3i Solar Atlas passed through our solar system at a strange angle. It used the gravity of our sun to gain speed. It performed a maneuver that physics cannot explain for a natural rock. It dipped low, swept past Earth, and then accelerated back out into the darkness. It did not attack us because that is not its job, and its job is to verify the source of the noise. Somewhere hundreds of light years away there is a listener. They heard our radio signals, our I Love Lucy episodists, our military radar, our pop music. But radio waves degrade over distance. They needed to be sure. They needed to know if the signal came from a complex civilization or just a natural phenomenon. So they threw a stone into the dark. 3i Atlas came to check the coordinates. It observed our atmosphere. It likely analysed the oxygen and nitrogen mix, which proves biological life exists here. It saw the lights of our cities on the dark side of Earth. It confirmed that there is a fire burning in the forest. Now the scout is leaving. It is heading back out to the deep void. It is silent again. It will not send a signal while it is close to us because that would reveal its position. It will wait until it is far away, buried in the safety of deep space before it transmits its data. The data will be simple: target confirmed, location verified, technical level low, threat level potential. The terror I feel now is not about what 3i Atlas is doing today. It is about what follows it. In the logic of the dark forest, once a location is revealed, the strike must be fast and absolute. You do not conquer the enemy. That is too risky. You do not enslave them. That takes too many resources. You simply extinguish the star. You clean the area. We used to look up at the stars and wonder if we were alone. Now I look at the night sky and I wish we were. The silence of the galaxy is not empty space. It is a breath held in anticipation. It is the quiet of a predator that has finally found the prey. 3i Atlas has seen us. It knows where we live. And now it is going home to tell the others. For decades the way we watched the universe was somewhat like looking through a keyhole. We would point our telescopes at a tiny patch of darkness, stare at it for hours and hope to understand the room on the other side. We found amazing things certainly, but we were always limited by where we chose to look. We were fishing in a vast ocean with a single line celebrating every time we caught a minnow. Now, however, we are about to remove the keyhole and tear down the door. High in the Chilean Andes, on the peak of Cerro Pachón, a new machine is coming to life. It is the Vera C. Rubin Observatory. When its massive eye opens, it will not just look at the universe, it will inhale it. This moment marks the end of the era where interstellar objects were rare magical visitors, and the beginning of an era where they become something else entirely traffic. The heart of this observatory is a camera, but calling it a camera feels like an understatement. It is the size of a small car weighing over 3 tons. It is the largest digital camera ever built for astronomy. To give you an idea of its power, if you wanted to display just one image taken by this machine at full resolution, you would need nearly 400 ultra-high-definition television screens arranged in a grid. This camera does not care about specific targets. It does not pick and choose. It is a survey machine. Every few nights it scans the entire visible southern sky. It takes a picture, moves, takes another, and moves again, moving with a speed and agility that seems impossible for such a heavy structure. Over 10 years it will create a moving movie of the universe. It will record everything that flickers, everything that explodes, and most importantly for us, everything that moves. This shift in technology brings a profound shift in atmosphere. For the last few years, ever since the discovery of the first interstellar object, we have felt special. When that first visitor arrived, it felt like a miracle. We gave it a name. We wrote thousands of papers about it. We treated it like a celebrity because it was the only one. It was an anomaly. But in the era of Vera Rubin, the anomaly becomes the routine. The math is simple even without writing down complex equations. We know that these interstellar wanderers are out there. Based on the 2 we have found so far, statistics tell us that at any given moment there are thousands of these objects passing within the orbit of Mars. We just haven't seen them because they are small, dark and fast. We were looking through that keyhole and they were slipping past us in the dark. The Rubin Observatory acts like a floodlight. It will detect objects millions of times fainter than what the human eye can see. It will spot these dark travelers not because it's looking for them specifically, but because it is looking at everything all the time. Predictions suggest that once this observatory is fully operational, we might find one of these interstellar objects every year. Some optimistic astronomers believe we might find one every month. Imagine how that changes our relationship with the sky. When you see a shooting star once in your life, it is a wish-granting magic moment. When you lie on a hill during a meteor shower and see one every minute, it is still beautiful, but it is no longer a shock. It becomes a part of nature. It becomes weather. We are moving from a time of discovery to a time of census. We will stop asking, is there anything out there, and start asking, how many are there today? This brings a feeling that is both exciting and slightly humbling. We are shifting from feeling like the chosen ones who witnessed a rare event to feeling small. We are realizing that our solar system is not a walled garden safe and isolated from the rest of this galaxy. It is a busy intersection. It is a highway. Every night, the Rubin Observatory will generate millions of alerts. An alert happens when the computer notices that something in the sky has changed since the last time it looked. Maybe a star got brighter. Maybe a galaxy shifted. Or maybe a faint dot of light moved in a straight line that suggests it did not come from around here. These alerts will be sent out to the world in real time. Within 60 seconds of the shutter closing, the data is processed and the message goes out. Astronomers all over the world will wake up to notifications on their phones. It democratizes the sky. You do not need to be the lucky person controlling the telescope to make the discovery. You just need to be the one paying attention to the data stream. This flood of data means we will find the weird ones. We will find the objects that look like rocks and the ones that look like comets. We might find objects that are made of pure metal or objects that are fluffy like cotton candy. We will find the slow ones that have been drifting for billions of years and the fast ones that were kicked out of their home systems by violent explosions. We will no longer have to base our understanding of interstellar space on just 2 examples. We will have a population. We will be able to do statistics. We will be able to say 10% of these objects are icy, or 5% are reddish. We will move from guessing to knowing. However, there is a melancholy in this progress. When something becomes routine, it loses its mystery. Oumuamua was a mystery that captivated the world. In the future, a similar object might just be interstellar object number 412. It will be logged in a database tracked by a computer and perhaps ignored by the public. But for the scientists, this is the dream. The giant eye of the Rubin Observatory forces us to accept reality. We are not living in a quiet, empty void. We are drifting through a galaxy that is teeming with debris, leftovers, and travelers. The space between the stars is not empty. It is full of things that have been waiting in the dark for us to turn on the lights. As the observatory begins its decade-long survey, we must prepare for the feeling of being overwhelmed. We are going to realize just how much traffic is actually out there. We are going to realize that the universe throws rocks at us constantly, and for the first time in human history, we will not just be blinking in surprise, we will be watching them all. The era of the lucky catch is over. The era of the dragnet has begun. By the morning of March 16, 2026, the concept of day and night had become entirely abstract for the crew. There was only the ship's internal clock and the overwhelming, terrifying presence filling the observation ports. Jupiter was no longer just a planet or a bright wanderer in the night sky. It was a wall of gas and gravity that seemed to swallow the entire universe. For weeks, the giant world had been growing larger, shifting from a distinct disk into a complex churning marble, and finally into a vast tapestry of violence that extended beyond the peripheral vision of the astronauts. Now, at the moment of closest approach, the ship felt less like a vessel under its own power, and more like a leaf caught in a hurricane. This was the day of the gravity assist, the most critical navigational maneuver of the entire mission. Without this interaction, the journey to the outer edges of the solar system would be impossible. They simply did not carry enough fuel to get there on their own. They needed to steal speed from the king of planets. The orbital mechanics required for this maneuver were precise to the point of anxiety. The navigation team back on Earth had calculated a trajectory that required the ship to thread a chaotic needle. They had to fly dangerously close to the planet, skimming just above the cloud tops in cosmic terms, to fall into Jupiter's gravity well. The plan was not to orbit the planet, but to dive toward it, letting the massive gravitational pull grab the ship and yank it forward. It is a concept that often confuses the layperson. How can falling toward a planet make you go faster away from it? The easiest way the commander explained it to the crew was to imagine a skater grabbing the back of a speeding truck. For a brief moment, the skater connects with the heavy moving object, swings around, and releases, shooting off with far more energy than they had before. In this celestial dance, Jupiter was the truck, As the ship fell toward the planet, it gained immense speed. If they had aimed directly at the planet, they would have crashed. But by aiming slightly to the side, that speed was converted into a slingshot effect. They were robbing Jupiter of a tiny, imperceptible amount of its orbital momentum and adding it to their own velocity. As the clock ticked down to the moment of periapsis, the point of closest approach, the silence on the flight deck was heavy. Outside, the view was both beautiful and horrific. The radiation counters were climbing steadily. Jupiter possesses a magnetic field of terrifying power, trapping high-energy particles that create invisible belts of radiation capable of frying electronics and killing humans. The ship had been hardened against this coated-in shielding, and with sensitive systems put into sleep mode, but the danger was palpable. The Geiger counters clicked with a frantic rhythmic static that served as the soundtrack to the flyby. Below them, the atmosphere of Jupiter churned. It was not a static surface, but a living ocean of chemicals. The Great Red Spot, a storm larger than the entire planet Earth, was visible near the horizon, a swirling eye of deep crimson and anger. The bands of the planet, striped in white ammonia ice and brownish ammonium hydrosulfide, moved at different speeds, creating shear forces that generated lightning bolts thousands of times more powerful than anything seen on Earth. The crew could see the flash of these storms on the dark side of the Terminator line, illuminating the clouds from within like deep-sea bioluminescence. At the exact moment of the flyby, the sensation of speed was illusory. Because they were in freefall, the crew floated weightlessly, feeling no G-force pushing them back into their seats. Yet the telemetry screens told a different story. They were accelerating rapidly, surpassing tens of thousands of kilometers per hour relative to the Sun. The planet was whipping them around its backside, changing their trajectory from a curved ellipse into a hyperbola that would shoot them out into the deep dark. This was the slingshot. It was a violent redirection performed with the grace of pure mathematics. As the ship swung around the dark side of Jupiter, the communications link with Earth was severed. For 45 minutes they were alone behind the massive bulk of the planet, cut off from the rest of humanity by 80,000 kilometers of hydrogen and helium. This radio blackout was expected, yet it induced a primal sense of isolation. In that shadow with the sun blocked out by the giant world, the darkness was absolute, broken only by the faint glow of Jupiter's rings' dusty halos that are invisible from Earth, and the distant icy sparks of its moons. When the ship finally emerged from the shadow of Jupiter, bursting back into the sunlight, the change in their reality was immediate. They were moving faster now, significantly faster. The maneuver had worked. The navigation computer confirmed that they had gained the necessary delta V, the change in velocity required to reach their destination years ahead of schedule. They had successfully surfed the gravitational wave of the solar system's largest giant. However, as the adrenaline of the maneuver faded, a profound emotional shift settled over the crew. This was the exit trajectory. Up until this point, they were still travelling within a neighbourhood of sorts. Mars, the asteroid belt, and Jupiter still felt connected to the inner warmth of the solar system. But Jupiter was the gatekeeper. By using its gravity to fling themselves outward, they were now on a one-way track to the void. Looking back through the rear telescopes in the days following the 16th of March, Jupiter began to shrink. It went from a wall of clouds to a marble and then to a bright star. But the most sobering sight was the Sun. From this distance, the Sun was already 5 times smaller and 25 times fainter than it appears from Earth. It was no longer a burning furnace that warmed the skin. It was just an intensely bright electric light in a vast black room. This marked the beginning of the true loneliness of the mission. The orbital mechanics that had saved them fuel had also severed their last psychological tether to home. The exit trajectory was smooth and silent. There were no engines firing, no vibration of thrust, just an endless silent coasting into the abyss. The ship was now a tiny metal speck falling outward, past the orbit of Saturn, past the orbit of Uranus, heading toward the frozen unknown edge of the domain. The excitement of the Jupiter flyby was replaced by the realization of the long cold quiet that lay ahead. They had left the harbour, and the open ocean of interstellar space was waiting. The show is finally over. The curtains are closing on one of the most beautiful celestial events of our time. As we move away from the excitement of discovery and the peak brightness that captured the world's attention, we enter the final chapter of the story of Comet Atlas. This is not a chapter of loud noises or breaking news, it is a chapter of silence, distance, and a long, slow goodbye. By the time we reach the year 2025, the comet will no longer be the dazzling object that fascinated stargazers. The warmth of the sun which woke it up and caused it to glow with a brilliant green atmosphere and a long tail will fade away. As Atlas travels farther from the centre of our solar system, the heat drops. The ice that turned into gas and created its beautiful tail will freeze hard again. The comet is returning to its natural state, a sleeping mountain of rock and ice tumbling through the dark. Into 2026 and 2027, Atlas will become a ghost. It will be so far away that only the most powerful telescopes on Earth and in space will be able to find it. To the naked eye, the spot where it used to be will look like empty black space bonds. It is a reminder of how fleeting these moments are. The universe gives us a rare show, and then just as quickly it takes it back into the shadows. This fading away is permanent. Unlike other famous comets that return every few decades or centuries, Atlas is likely on a path that will take it away from us forever. It has enough speed to escape the gravity of the sun, it is not just taking a long lap around our star, it is leaving home. It is heading out into the vast empty ocean between the stars. It may drift for millions or billions of years before it ever gets close to another star system. This realization brings a feeling of deep solitude. We were the only ones to see it, and we will be the last to see it. As the comet disappears into the dark, we are left with the silence of the aftermath. But this silence is not empty. It is filled with the knowledge we gained. We have learned so much during this brief encounter. By studying the light reflecting off the comet, scientists have analysed what it is made of. We have found carbon, the building block of life, and water, the essential ingredient for survival. We have learned that the ingredients that make up our own Earth are not unique to us. They are floating out there in the deep freeze of the solar system waiting to be found. This teaches us a profound lesson about our place in the galaxy. We often feel isolated on our little blue planet, separated from everything else by millions of kilometers of nothingness. But the visit of Comet Atlas reminds us that we are connected. The solar system is dynamic and alive. Objects move, travel, and interact. The material inside that comet is the same ancient stardust that makes up our bodies, our oceans, and the ground we walk on. We are part of a giant interconnected web of matter that spans the entire galaxy. As the year 2027 approaches, the comet will cross the invisible boundaries of our planetary neighbourhood. It will drift past the orbits of the giant planets Jupiter, Saturn, Uranus, and Neptune. It will pass them in the dark, a tiny speck against the backdrop of the Milky Way. The sun will look smaller and smaller until it is just another bright star in the sky, no different from Sirius or Vega. The comet will no longer feel the sun's gravity pulling it back. It will be free. There is a certain peace in this departure. When the comet first arrived, there was chaos. Astronomers were rushing to calculate its orbit. Photographers were fighting light pollution to get the perfect shot. Social media was buzzing with updates. But now as it leaves, the noise has stopped. The urgency is gone. What remains is a sense of acceptance. We accept that things change. We accept that beauty is temporary. We accept that some visitors are only meant to stay for a little while. In this quiet time, we can meditate on the legacy of the traveller. What does it leave behind? It leaves behind data in our computers that scientists will study for decades. It leaves behind beautiful photographs that will be printed in books and hung on walls. But more importantly, it leaves behind a feeling of wonder. For a few months, millions of people all over the world looked up at the same sky, and we forgot our differences and our borders, and we shared a moment of awe. That is the true gift of the comet. As we say our final goodbye, we can imagine the view from the surface of the comet. It is cold, nearing absolute zero. It is silent. There is no air to carry sound. The stars are unblinking diamonds, sharp and clear. Behind it, the solar system is shrinking. Ahead of it lies the great unknown of interstellar space. It is a lonely journey, but it is a majestic one. So we send a final wish to this frozen wanderer. Travel safe, little rock. Carry the story of our sun and our world into the deep darkness. You were a messenger from the dawn of time, and you brightened our nights for a brief magical season. Now you belong to the galaxy. The fade is complete. The telescopes turn to new targets. The sky is dark again. But in our minds, the tail still streaks across the stars, a memory of light that will not easily be extinguished. The silence returns, but it is a silence full of respect for the vast, beautiful, and endless dance of the universe. Goodbye, Atlas.